The first thing you need to know is in this class there's going to be a lot of vocabulary, and most of this vocabulary is written on your sheet so that you don't necessarily have to know what's going on. Individuals are the objects described by a set of data or data. Individuals may be people, but they might be things as well. A variable in statistics is any characteristic of an individual, and a variable can take different values for different individuals. Something that's categorical puts something into a group or category, and something that's quantitative takes a specific value. So basically, categorical values would be things like hair color or gender, things like that. Quantitative would be like your age or your IQ, your GPA. Distributions of a variable tells us what the values the variables are taking and how often they use them. So for example, you might see that the number of people in this class who are 17 is 32 people. And that's what they're talking about with the distribution. So the number 32 would show up in a table. Our first example is Jake is a car buff who wants to find out more about a vehicle or vehicles that high school students drive. He gets permission to go to the parking lot and record some data. Later, he does research about the model of the car on the internet. Finally, he makes a spreadsheet that includes the car's model, year, color, number of cylinders, gas mileage, weight, and whether it has a nav system in it. So what, in this particular example, are the individuals? The cars. So if you're looking for the individuals, these are our cars in the parking lot. And what variables did he measure? And then let's talk about whether or not they're categorical or quantitative. So what's one of the things he talked about? A model. What kind of thing is that? So that's categorical. How about the next one? Okay, so nav. What's that? Categorical. Year. Quantitative. What else? Color. That's categorical. It's not a number. Number of cylinders. So since it has a number, it's quantitative. Sam?
Wouldn't year be categorical because you don't find like the average?
Anytime that they use a number, they consider it to be quantitative.
Okay.
Weight.
Oh, and then MPG.
So that's quantitative. Miles per gallon. Quantitative. Did we miss anything?
Nope.
7 things. Okay, sounds good. All right, so the distribution of a categorical variable lists the categories and gives the count. How many of those showed up? That's called a frequency table. Or sometimes they write it as a percentage. That's called a relative frequency. Pie charts and bar graphs oftentimes are used to display these things, these categorical variables. Pie charts can only be used if it's part of a whole, because pie charts are talking about out of 100%. So kind of a big note to put off to the side here for pie charts. You have to have it total up to 100%. If it doesn't total up to 100% of the things that you're talking about, you cannot use a pie chart. Graphs can be used in many different groups so long as the quantities are measured in the same unit. Now, one of the things that's kind of important when you're making any of these graphs, any graph whatsoever, you should always have a title, and you should always label. That's the biggest error that's made on the AP Stats exam in May, is when you draw a graph, if you don't label in each like pie piece, you know, what you're talking about, or if you don't give the graph a title, that's kind of a problem. So let's try an example here. So here are the percents of 15 to 18-year-olds who own the following personal media devices. So cell phones 85%, MP3s 83%, video games 41%, iPads 36%, and laptops 28%. Notice that they are not mutually exclusive. That means you could own more than one thing. What graph can't I use? A pie, because this would total up more than 100%, so you are not allowed to use a pie chart. All right, I would like you to try and create a bar graph for this data, and then afterwards I'm going to put up mine and let's see how close we are. Okay, so as I think about this, the first thing I'm going to do is I'm going to give my graph a title. How many people gave their graph a title? Nice job. So I would call this personal, personal media devices. This doesn't necessarily have to be your title, but it should be titled. And then since it's out of 100%, I'm going to make my top bar 100% and then maybe go up by 20s. And label so that the reader of my test knows that I have a scale on my graph. And I would call this the percent owned, I guess. And then down across the bottom, of course, would be the different devices. So my first device, if I was going to do cell phone, which is 85%, I could make a bar at about 85%. Call it cell phone and label it CP maybe for short. And then what I like to do, to make sure the reader can't mess up on my test, is I like to put the number at the top of the bar. It's not required, but it helps the reader know for sure that you knew exactly what the percentage was. And then the next one would be the MP3 player. It's a little bit shorter than the cell phone.
Do you have to go in that order?
Nope, not necessary. You can put it in any order you like. Video games, how big? 41? Whoa, that's a big drop. And then iPad, 36. And laptop, 28.
Do they allow colored pencils on the EP exam?
Well, that's a good question. I don't remember off the top of my head. I don't think so. And you'll notice that along the bottom are the labels. And what you should do is also title what the horizontal axis is. So the horizontal axis is talking about all the different kinds of devices. So down here I should put devices. So notice that there is a vertical axis label, a horizontal axis label, and a title. So this next question we kind of talked about a little bit before. Is it appropriate for a pie chart? No, not really. So the answer is no here. And you can say it one of two ways. This is the total percentage is more than 100 is one thing. And all the items are not part of a whole. Meaning that these are not all adding up to one total amount of, like iPads, for example, generation 1, 2, 3, that kind of thing. So that's why a pie chart is not appropriate. All right, two-way tables. Two-way tables are very popular in statistics. And all it really means is that there's a heading across the horizontal at the top usually, and one across the vertical on the left usually. And it organizes our data into two categorical variables. They're often used to summarize large amounts of information. And a marginal distribution is the distribution of values among all of the individuals. That's kind of the important thing. So when you're thinking about that and you're looking down below in the table, when they talk about all the different values, they're talking about this number 200 here. So when they talk about marginal, they're talking about a percentage, and it's out of the total of the whole table. Let's look at an example. Those are oftentimes the best way to figure these things out. So 200 children from the UK between 9 and 17 were selected at a website. The gender was recorded, along with the superpower that they would most likely want to have. Invisibility, super strength, telepathy, flying, freeze time, and here are the results. Again, I'm going to label when I make my table. So we're going to use the data in a two-way table and calculate the marginal distribution in percentages of these superpowers and make a graph to display it. We're going to do both. All right, so first of all, if I'm making a table, or actually not a table, but making a graph, which I think would be the easiest, I'm going to have a vertical and a horizontal axis. I'll make this off to the side here. And since they're talking about percentages, these are going to be out of 200. It looks like the largest number out of 200 for each of these, if we're talking about totals here, is 54. So that's not really more than, I don't know, 25%, right? So as I make my graph, I'm probably going to make the highest percentage 25. And then go by fives, maybe 5, 10, 15, 20. These are the percents. And then down below, these are the superpowers. And then I can calculate these off to the side. So I need to figure out off to the side, sorry this doesn't really go the way I need it to, which different superpowers I have. So first of all, what I want to know is what's the superpower that I have. And then what I want to know is the percentage that contain that superpower. So the first one, the first superpower is invisibility. If I look at invisibility, and if somebody could please calculate the 30 divided by 200, 15% I'm thinking, right? Seems easy. So 15 out of 200 is invisibility. Now let's use I to label that. So for my second superpower, we have super strength. And super strength is 20 out of 200, and that's 10%. And then the third one is telepathy. And that's
22%.
22, thank you, 22%. And again, if I want to, I can write these at the top of the bar so that there's no mistake what's going on with my bar graphs. Here, talking about the distribution. My next one is the flying. 27. Thank you. Oh, I was off on that. Darn it. And that one was empathy. And my last one was freeze time. And the freeze time, 52 out of 200.
26.
26. Thank you. And if we're describing what we would see here, it seems like freeze time and flying are the most popular superpowers, and super strength is the least popular. So that's some observations I could see from the table right away. Conditional distribution, which is a little bit different than marginal, describes the values of that variable among the individuals who have that specific value of another variable. There's a separate conditional distribution for each value of the other variable. So this is talking about the specific powers, for example, kind of deal. So looking at side-by-side comparison, you can do two different things. You can do a segmented side-by-side bar graph or a segmented bar graph. And so if we look at